Hey guys, and welcome back to Mela RC. Today we're going to be doing my first tutorial video. This video is going to be about how to set up one of these balsa wood, extreme flight, whatever brand you have, small 3D electric aircraft properly. I've been getting some comments on my videos, specifically this airplane here, asking, what do you recommend and what's the best way to set one of these up, because most of the guys are coming from the foam, plug and play, or bind and fly airplanes, and those are already done for you at the factory. Well, this, you have to do it yourself. So for first time guys, it can be a little bit confusing, and I'm going to hope to take that confusion out for you in this video. So I have a video of this airplane on my channel. This is the Extreme Flight X300 EXP version 2. Super sweet flying airplane. This is the 48-inch size. This is going to be the size that I am going to assume most of you guys are going to be starting out with, just because they're the cheapest. It's the cheapest one, and you're not going to put a whole lot of money into 3D just yet. So, all right, so we're going to go ahead and pull off the canopy and get started. Okay, so we have the canopy off the airplane here, and you can see we can see the compartment inside. So let's go ahead and talk about my setup and what I recommend. So as you can see, here's the receiver. It's very basic. It's a 6-channel receiver, and the first thing I want to make clear is actually 6-channel is what I recommend instead of 4-channel. I know these are 4-channel airplanes with 5 inputs. You see we got the throttle, 2 aileron servos, and 1 for each tail surface. So but 6-channel is actually what I would consider the minimum for me, and I'll talk about that later. But the first thing that I want to say that a lot of beginners are probably going to think about, and I would absolutely do not recommend, are your aileron servos. As you can see, we have 2 of them, like I was saying. But one goes into the aileron like normal, and then the other aileron actually goes into this gear. Normally on maybe like the foam airplanes you guys are used to, you're probably going to see something like this. This thing is called a Y harness, and in my mind, a Y harness is one of the worst wiring options, especially for 3D airplanes, for dual servos on one control surface axis. The reason is because with a Y harness, you can't adjust individually one of your servos. If you try to adjust your left aileron servo, your other aileron servo is going to move as well. The reason for this is because in my case, 99.9% of the time, the servos that we buy for these airplanes, high torque, high speed, do not move the same amount, or the servo horns do not 90-degree the case the same either. And you want to be able to adjust that individually. You can't do that with a Y harness. Instead, I'd recommend this. You take the radio. I do have to say this, if you're getting into airframes like these, and you want to progress on, you're going to need a computer radio. And for these airplanes, you will need a minimum of I'd say a minimum of a 6-channel computer radio. Although when you get into the bigger airplanes, like a 30cc size over there, I recommend actually getting a higher, like maybe 12 or 10, but that's later on down the road. But here's why I recommend not using a Y harness and what I do instead. I go to this radio. Luckily, if your radio can assign channels, you can see I've assigned that gear as the left aileron. So what that gives me the advantage of is adjusting each aileron servo individually. That is why I do not like using a Y-harness, because I'm able to get the same amount of up and down throw on both my ailerons, which with these airplanes is something that you want. Okay, so that's that's a really big one that I really wanted to get out of the way. That is pretty much my biggest no for setting these things up. So let's go ahead and talk about how I am actually powering these servos, because normally with your other models, they are powered through the motor, you know, has an ESC. Well, that ESC has something called a BEC, which is basically a voltage regulator, because this airplane runs on 4-cell, and that's 14.8 volts. Problem is these servos, or normal servos, can only handle 4.8 to 6 volts, so you can't plug a 4.8 volt battery into servos or receiver for that matter, because it'll just fry them. It's way too much voltage. So that ESC has something called a BEC, which stands for battery elimination circuit, and that basically takes 14.8 volts in my case down to 6 volts. Now this is traditionally. I'm actually doing something different, because these servos right here that I'm running, I'll go ahead and show them to you. I don't know if you can see them or not. Maybe too dark, but these are Pro Modeler DS75 CL high voltages. And what that means is these servos can actually handle a little bit more voltage than standard. And I'll show you them right here. There's specifications of these servos. You see voltage right there, 4.8 to 8.4. Traditionally, regular servos are going to run from 4.8 to 6 volts. So this can handle quite a bit more voltage. The problem is you still can't plug a 4-cell battery into the servos or receiver. That'll still fry them. So, and then another issue is this BEC and this ESC can only supply, if I remember correctly, about 6 volts. Well, if you read these specs on these servos, you can see the speed range right there. On 4.8, they go 15 seconds, and then on 8.4, they're 0.015 seconds, and 0.078 on 8.4. The torque is also the same way. You can see there. It's lower on 4.8 volts and higher on 8.4 volts. When you're flying 3D planes like these, I absolutely recommend you get the highest voltage possible to your servos. So, how do we accommodate this problem? There's 2 ways you can do this, and I have my favorites, what I don't like. Here are your 2 options. You can get a separate BEC, which has an adjustable output. As you can see here, this is a standard Castle 10-amp BEC that's been around for years, and it's a really great RC item. A lot of people use this, and it's super great. But you can see, you can adjust the voltage. It says 4.8 to 9 volts. That's another way to do it. This is my personal preference. I like to use an actual 2-cell LiPo battery, which is at 7.4. Now that's nominal voltage right there at 7.4. At full charge, this is going to be around 8 volts, like these servos can handle. So there are disadvantages and advantages to both, and we'll talk about them now. And as you can see, what you do is you just find a battery with, a servo connector on it, and that works just fine. Or in my case, I like to solder my own, and I like doing that. As for the BEC, how you do this is you just solder positive and negative to your battery connector on the ESC side, and that works great too. So let's talk about advantages and disadvantages of both. The disadvantage for the LiPo is obviously you get a number amount of flights. You know, you keep using the servos and the receiver. The voltage is going to lower down. The battery's eventually going to run out. But I can tell you, I get about 4 flights with this pack easily. And this is just a tiny little 300 milliamp 30C pack powering these 4 servos. And that gives me, you know, 5, 6 flights, which is plenty for me. A BC, obviously, you don't have to worry about charging. You just plug it in, and it's ready to go. Also, the battery is going to be, well, these 2 batteries here weigh about the same. But when you get maybe a 60-inch size airframe, or you get into the big electric guys, a BEC is going to be probably a little bit better just because it's going to be lighter, because you don't want a little 300 milliamp on maybe a big electric airplane like that. The servos are going to take more amps, and you're going to want a little bit bigger of a battery. All right, so that's pretty much what I can think of the disadvantage of the LiPo. The disadvantage of the BC, and what kind of takes the cake for me and which makes me switch over to LiPo, is this has a constant current and is going to deliver what those servos need. A BC is constantly on. And what that means is, let's say we're just doing precision aerobatics, you know, like in using small control movements. This battery is going to give the servos what it needs. This thing is going to be on full amperage and full power constantly all the time. So there's kind of wasted power in that. That's kind of one reason why I don't like using a BEC, especially in these these smaller airframes. The second reason is because this sends its signal in pulses. In other words, it switches on and off really fast. So fast that, you know, the receiver can't... it's so fast that, you know, it acts like a fluid motion. Problem is if you do like a fast snap roll, or you throw all your control surface in the corner, if you are on that lower spike, sometimes you can experience a little bit of drag on your servos, or not drag on your servos, but it's a little bit sluggish. Your servos don't have the full amperage or power it needs if it's on that lift, if it's on the low end when it's pulsing. You know, on the high end you won't feel it, but on the low end you kind of will. And if you pull too much voltage and amperage, sometimes you can actually brown out your receiver and kill your receiver as well. That's kind of what I heard. That's what I've heard. I've never personally had that happen to me, but I do know that this is constantly, you know, has constant power on all the time, when this just feeds the servos exactly what it needs. If you're just using small control movements and then full snap roll, this is going to provide the power that your servo is going to need all the time when you need it, and then it conserves the power. So it's, in my mind, it's a little bit more efficient. So that's kind of why I lean towards this LiPo. Another reason why I like it is because when I want to adjust something on the plane, say servos or anything, I don't have to get my big flight battery out. I can put it in, put the battery in, plug in my receiver, and the motor's dead, and the motor won't turn on, and it's light. I can, you know, I won't have the weight of the battery. It won't fall out or anything, and that's why I also like the LiPo. It makes setting up so much easier. Now, if you are going to run high voltage and you use either the BC or the battery, one thing you have to do is disengage the ESC's battery eliminator circuit, because you don't want this battery eliminator circuit and this LiPo plugged into the receiver. They're going to constantly fight each other, and you're going to have problems. So, what you do is I'm going to cut the video here and unwrap this tape, and I'll show you. Okay, so we are looking at the throttle plug-in that normally goes into the receiver. And as you can see, I have disengaged the red wire here. And all you do is there are these little prongs. I don't know if it'll focus or not on there, but there are these little prongs, and you just lift those prongs up. Oh, I had it on focus. There we go. You lift one of those prongs up with like a hobby knife or something, and then you just slide the red wire out. That disengages the ESC's battery eliminator circuit, so you can run these high voltage power supplies like the battery or your separate BEC to your servos. So that's one thing I wanted to make sure. You have to make sure you do this if you're running a separate power source for your servos and receiver for your radio gear. All right, so that pretty much covers radio setup. I'm going to flip the airplane over and talk about one more thing. Okay, so we are looking at the elevator servo. And a couple things and the last thing I want to cover is proper servo arm placement. In other words, the biggest thing that you want to do when you're installing your linkage here is you want to make sure your control arm on your servo is completely 90 degrees to the case. You can see it isn't like, it ain't like that or like this. You want it perfectly 90 degrees at neutral. Use your radio sub trim to adjust. Find the closest, tooth position that gets closest to 90 degrees, and then use your sub trim to take care of the rest. So that's just one more big thing I wanted to cover. And other than that, just make sure these linkages are nice and tight. This is going to be the common linkage you're going to see. It's called the ball link setup. And just make sure everything stays tight. I'm using the nylon lock nuts, and those in my mind are nicer than just regular nuts, just because, you don't have to use Loctite and they're never going to come undone. They're vibration resistant compared to regular nuts. So that's another thing I like to use. Another thing is, you can see the control rod. It is angled down a little bit. It's not perfectly straight. There's some misconceptions that has to be perfectly straight. It honestly doesn't. You do want it as straight as possible, but it can be just a little bit. You don't want it like 45 degrees. You don't want it too far off, but for an elevator like this, it's not as bad, because we can get really, massive throws up to 70, 65 degrees there. So it's really, really nice. And all these servo geometry and everything is done from the factory, because they send you these extensions, so you don't have to worry about proper servo alarm length and anything about that. So, all right, so we're going to go ahead and flip the plane over and finish up this video. All right, guys, so that is the advice I have for you guys about proper radio setup for this. If you guys have any questions or anything I missed, put them in the comments below, and I'll do my best to answer them. But I did want to do a video covering kind of specific the radio setup, because a lot of people, they get kind of, they don't know what they have never seen. Some people have never seen, using a separate battery or a BEC like this before. So kind of what I wanted to do was, take the mystery out of how to do the proper setup, and why I prefer a LiPo over BEC and all that. So, anyway, yes, if, and once again, anything I missed, put them in the comments or any questions, and make sure y'all like, comment, and subscribe, and I'll see you guys next time.